Even today, we see extreme cases where a patient can lose a limb because of an infection that can't be treated with antibiotic. With the amount we know today of sterilization today, we should be taking every precaution to prevent HAIs. Here we have an example of a staph infection and a surgical site infection. Our goal is to avoid infections and to ensure that we are doing everything possible to prevent them. Ultimately, we want to reduce microbiological contamination to a level that an effective dose is unlikely to reach a susceptible site on a patient. When it comes to producing sterile instruments, there is a simple 5-step process to sterilize instruments. Each step is important from washing to storage. After you wash and dry an instrument, you place it into packaging to maintain the sterility. Then you sterilize it and store it in a clean, dry location until you're ready to use it. When we talk about cleaning surgical devices, we take into account a number of factors. To determine how to clean a device, we consider the bioburden or the amount of bacteria on the surface of the device, and whether the device is critical or not, and where on the body it is used. With general surgical instruments, we're talking about a low bioburden. With GI scopes, we're talking about a much higher bioburden. Disinfection or sterilization processes must include cleaning to remove microorganisms that can be found in the residual soil and to remove residual soil from the device. The important point to remember here is that sterility cannot be assured for sterilized instruments rinsed with water. The sterilization process isn't generally recognized as delivering sterility assurance of 1 in a million chance of a non-sterile occurrence. Steam under pressure is the only practical way to sterilize water. Liquid sterilization, which uses chemicals, can corrode instruments. Steam can leave traces of salt, which corrodes, and steam also can dull cutting edges of instruments. All may result in greater repair costs. The STERRAD technology, which uses low-temperature sterilization, is proven through scientific study to be gentler in steam or peracetic acid, even on the most delicate instruments. The bottom line is lower repair costs for instruments. One of the most important things that you need to know when sterilizing equipment is whether a particular device falls within the cleared claims for sterility. At ASP, we provide the STERRAD Sterility Guide. ASP's STERRAD Sterility Guide is designed to provide STERRAD system customers with a list of devices that fall within the cleared sterility claims. It is an easy-to-use online tool which uses simple 3-step process and is available 24 hours a day, 7 days a week. With a few clicks of the mouse, you can quickly determine if a device can be sterilized in a STERRAD system. ASP works closely with leading medical device manufacturers to validate sterility claims. For further information, please contact your medical device manufacturer directly to ensure the STERRAD NX system will properly sterilize your device. For medical device contact assistance, please visit www.aspjj.com/alternatives. With more than 14,000 units in use in hospitals and healthcare facilities around the world, STERRAD sterilization offers the most productive solution for low-temperature sterilization needs. It is a legally marketed terminal sterilization system engineered using ASP's breakthrough gas plasma technology. STERRAD sterilization systems sterilize your instruments and medical devices safely and effectively without the limitations or risks associated with peracetic acid, steam, or ethylene oxide systems. The sterility guide that I mentioned earlier allows you to quickly identify devices that fall within the cleared claims for sterility. Finally, the STERRAD sterilization systems produce a measurable return on your sterilization investment by reducing instrument repair costs, offering rapid cycles, reducing instrument inventories, and enhancing safety.